Hi, today we're going to be discussing proportional relationships. This is something I've been doing with you all year in one way or another. Many problems in mathematics are actually direct proportion problems. Things like if we've got all our percentage problems are what is 30% of let's make it nice and easy, let's say £630. Now, proportions allow us to solve this using mental methods by saying, well, if I know what 30% is 630, I can divide both numbers by 3, and that will give me another proportion that still works. I can work out what 100% is by taking that 10% multiplied by 10, and that said, oh, the total amount originally was 2,100. Anything that can be done in this way is a direct proportion. It relies upon two facts. The first one is that each change of the value on the left-hand side has a similar scaling factor on the right. That's what we're talking about, is scaling values. The second one is you must meet the following requirement. What is 0%? Well, it's no pounds. Now, the beauty with proportions is if I was to look at them as a graph, I put in 0, 30, 60, 90, and that's my percentage, and I put in my money going up the side, let's say about 500, 1,000, 1,500. I need to actually take this scale a bit further, the money. What we've got is 100% is 2,100, so 100%, 2,100, it's about there. 30% was 630, that's going to be a bit underneath that one. We said 10% was 210. 210 is just under halfway to 250. And what we actually find is if we draw a straight line, from 0, 0, it will go through all those points. And they will all sit exactly on that line. That is a direct proportion. It says that I can either do a little step, so I could actually do a step by going for every 10 across, I got 210. So my next one, go 10, this would be 420. Go again, and we get 630. Oh look, that's my 30%. That's what a direct proportion does, is it goes up simply. Now you may realise there's also another effect. If I was to calculate the gradient of this line, we should always get the same number. So a gradient for this line is, I'm going to take them from 0. So let's do 630 divided by 30. 630 divided by 30 is 21. What is 210 shared by 10? 21. 2,100 divided by 10 is 21. 0 divided by 0, no answer. That's the only weird part, is you can't do that. This applies not just to particular points, but differences between points. So for two things to be in direct proportion, you must be on a line which has the same gradient, and it must go through 0, 0. It must go through there. If it's got a constant gradient, but there's an amount added, things like couple of situations where this happens. We'll do a direct proportion, another one. Current rate is £1 is about the same as about 400, I think it's nearly 500 tenge now. So £1 is 500 tenge. That means I can use that calculation. If I've got no pounds, I get no tenge. If I've got £5, I'd expect to get 5 times that, 2,500 tenge. So that sort of direct translation of a certain amount gives me another fixed amount, always gives me a straight line. There is a problem though with currency ones, and it's not often in the questions, but in reality, these exchanges are not in a direct relationship. They are here, but in reality you have commission. And what the commission does to the graph is normally they do it in stages, but at the simplest stage, at a simple translation, a simple amount of money. If I put transferring pounds into tenge, come on, give me my pen. So pounds to change into tenge. If I've got 1, we'd say that's 500. 1, 2, 3, 4, 5. 5. That's 1,000. 2,000. 3,000. 4,000 at the top. That's 5, 2, 4, 10. So £1 gives me 500 tenge. £5 gives me 2,500. Oh, and that's not 1,000 there. So my line creates a straight line going through 0, 0. That is an ideal conversion. Certain places will get this. Normally, international companies, they would not charge themselves for exchanging money between their two countries. So they might get this idealized one. But in reality, what happens is you'll get given a clause that says the cost of or commission, it's called. You can be given a commission in 2 ways. If it's as a percentage, we would wind up still with a proportion. But often the cost of commission has a fixed amount, and they would say things like, it costs you 400 tenge for to exchange the money up to £100. And what this does is, if I try exchanging £1, they're only going to give me 100 tenge. If I try changing 5, I get the 2,500, but they're going to charge me 400 tenge to do it. And this graph then actually comes through, and it doesn't go through my origin, the 0, 0. So this is with commission, and that means it is not a direct proportion. So with commission, it is not directly proportional. Okay. Other examples where we don't get proportionality. If I was to do we'll go back to circles. The radius of a pizza to the area of the pizza. Now the type of graph that gives me starts off with a nice radius of 0 and an area of 0. So I get radius and area. So it meets one of the requirements, but when the radius goes to 2, my radius is 2, remember A is pi times r squared. When my radius is 2, we're going to get 4 times about 3, which is about 12. So that's 12. 24, 36, 48. So when I go to 4, I've got 16 times a 3, which is about 48, from that point there. If I try a radius, so radius 2 gave me an area of 12, a radius of 4 is 16 times 3.8. That should be, actually, I think that's 49, not 48. Multiplied by 4 squared. Yeah, that gives me 50 actually. It's a little bit over. When I go to 3 times pi, 3 squared times pi gives me 28. So there's 24. 28 is a little bit above it. And if you look at this graph, let's just do it for fun. 1 is going to give me 3. This graph does not have a constant gradient. It changes as we go through. So as it goes up, it does not change by a uniform amount each amount. So a lot of problems are often in some way proportional, and one way to solve them is by calculating equivalent fractions. That's what we've been doing with things like percentage calculations here. My little trick of saying, if I know that 30% is 630, and my question sorry, £630, and saying, right, I can write that fraction so that if I want to know what 70% is, what's x, I can rearrange to say x equals my £630, drag it to the other side and multiply by 70 over 30. So 630 times 70 divided by 30 is 1,470 pounds. The whole reliance here is that we've got the gradient in the middle here, this proportion. There is a gradient part that is equal to both these fractions. So 70, actually, sorry, wrong gradient, the gradient isn't correct there. The gradient is in the line. So if I then do 1,470 divided by 70, that gradient is the same as every other one, and it actually comes out as being 21 again. So that's how you can do your gradients. So what I've set you as a task is to do some Khan Academy questions. Usual thing, try and get 7 questions right in a line. Do keep notes of any calculations you do along the way to show what's happening. And I'll quickly show you what we can do with this one to help. I'm going to use Khan Academy's calculator, but you're welcome to use your own. So I need a calculator, which is at the bottom, I think. Where's this calculator gone? Oh yeah, show calculator. So I can drag that around in my window. It does stay within the browser window though. Sorry, I was just touching my pad in a funny way. That's why it kept flickering. So I'll drag the calculator over here so I can do some working. They've given us some bananas and the number of pounds. Pounds is the weight the Americans use. It doesn't matter which way around you do the division, but as long as you keep doing it either dollars divided by pounds or pounds divided by dollars, you should always get the same gradient for each line. So I'm going to do the 1.47 here. That's the cost in dollars, divided by 3. And that gives me 0.49. So anything that's in proportion, in the same proportion as these bananas, should give me a 0.49. Let's try the 2.45. Divided by 5. Gives me 0.49, same proportion. The 4.41 divided by 9 equals 0.49 again. So these are all in proportion. They've all got 0.49. So to check these, let's do that one. Hopefully you'll recognise that as being twice of 49 pence, so I know that one's correct. There are 3 correct answers though. Make sure you check how many answers you need. 4.45 divided by 7. Remember, I'm doing money divided by number of bananas, or pounds of bananas. 4.45. Does that divide by 7 in the same proportion? No, so this is not the one in. That means that, oh, I haven't checked yet. 2.94 divided by 6. Is that in proportion? Yes. So that's my second answer. 0.54 divided by 1? No. So it's going to be this last one, but let's just check it. 3.92 divided by 8. 0.49. So there's my three answers. Give it a check. It says I correctly selected that one. I didn't select it. I correctly selected that one. I correctly selected that one. So I'm now well on my way towards getting my bonus. Any calculations you're trying to do along the way, please show them. When you finish, yes, please do the screenshot of what you get there. If you've logged in to this, you should find it as an assignment in your tasks, and it will actually record your score as well, but please send me a screenshot. So when you've done your 7 questions, have you screenshot it, attach it to your screen. Right, good luck with that, and we'll be combining these ideas together in the next few lessons.